Current electricity numerical, July 2017. 3 resistor 4 ohm, 6 ohm and 8 ohm are connected in parallel. What is the total resistance of the combination? Now here it is, 3 resistors 4, 6 and 8, they are connected in parallel. What is the effective resistance of this combination? Here it is given by very simple formula, that is 1 by effective resistance, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now what is R1? Here R1 is 4, R2 6, R3 8. Here it is 1 by 4 plus 1 by 6 plus 1 by 8. Take a LCM and you can write 6 plus 4 plus 3 is equals to, that is 13 by 24. That 1 by effective resistance is equal to 13 by 24, or that Rp is equals to 24 by 13. That's equals to 1.84. What is that? This is the effective resistance of the combination, or say that is total resistance. Total resistance of the combination is, that is 1.84 ohm. Here part B. If the combination is connected to a battery of EMF 25 volt. Now if this combination, this is the combination, is connected to a battery of potential or a EMF 25 volt and negligible internal resistance, that's why here small r is equal to 0 anta bardive. Determine the current through each resistor. Here you need to find I1, I2, I3, that is the current through each resistor, and total current drawn from the battery. Here the total current drawn from the battery, that is I. Here we need to find when this combination is connected to a battery, its EMF is 25 volt and it has a negligible internal resistance, then you need to find the current through each resistance and the total current through the combination. Here total current drawn from the battery. For that we have a very simple formula. Main current is equals to I is equal to EMF divided by Rp, that is external resistance, plus internal resistance. Here in our case internal resistance small r is equal to 0, that is negligible resistance, and EMF of the battery is 25 volt, and Rp, that is just we have calculated, the effective resistance of the combination is 1.84 ohm. Here it is 1.84 ohm. Now 25 divided by 1.84, that gives I is equal to 13.54 ampere. What is this? This is the total current drawn from the battery. Here this is the total current I, which is 13 point something. What is that? It is 13.54 ampere. The total current drawn from the battery is 13.54 ampere. The next thing is we need to calculate the current through individual resistor. How to calculate? Again, it's a very simple. We need to calculate the branch current. In parallel combination, the potential V remains same. Therefore, I can write I1 is equal to V by R1. Here V is 25 volt and R1 is 4 ohm. Therefore, I1 is equals to 6.25 ampere. Here I2 is equals to V by R2. V is 25 volt and R2, that is the resistance of our second resistor, is 6 ohm. 25 by 6 is I2 is equal to 4.16 ampere. Here I3 is equals to V by R3. Here R3 is equals to 8, that is the resistance of our third resistor. 25 by 8, that therefore I3 is equal to 3.12 ampere. What is this? Okay, these are the current through each branches. Okay, current through the first branch, current through the 4 ohm resistor is 6.25, current through 6 ohm resistor is 4.16, current through the 8 ohm resistor is 3.12 ampere. Here, that's what is it? Determine the current through each resistor and total current drawn from a battery.